All right, welcome back to another lesson for Math 7. This is going to be lesson 104, which is semicircles, arcs, and sectors. And so semicircles are half circles, arcs are part of the a part of the circle with flat lines, like an arc, right? And then sectors are actually a part of the circle, like a pizza slice. It's the easiest way to think about it. So we're actually going to get into it because this lesson is not very hard, but it's something that you guys need to understand. And these two next lessons, 104 and 105, have to do with geometry. So please understand that you have to know your formulas, okay? I could explain all I want and, show you amazing examples and everything. But if you don't know your formulas when you're doing your math, and by your formulas, I mean perimeter and area of squares, triangles, rectangles, circles, you're going to be in a lot of trouble. So you have to know them, okay? I will remind you of the ones that we're going to go over, but understand there's other things that you have to know, okay? So let's actually dive into the lesson. All right, example 1. So we have this shape, which looks, when I was drawing it, it looked like the bullet in Super Mario Brothers. Or Super Mario Bros. All right, so it looks like a semicircle attached to a rectangle, and I know my rectangle doesn't have that, but you guys have wonderful imagination, so let's just use them. Yay! Because math is super fun. And so what we're going to do here is we're going to find the perimeter. I think it's what they asked us. Where's the perimeter of the figure? And then the dimensions are in meters. So very important. For circles, do we find perimeter? No, absolutely not. We need to find circumference. And then I'm going to show you what circumference of a circle is diameter pi. And I'm going to stick with that one, okay? Although for this purpose, this is called a semicircle because it's half of it, semicircle, same thing, potato, potato, tomato, tomato. And so what we're going to do is we're going to find the other area for the circumference of a full circle, which is 2 pi radius. But if it's half of a circle, then we're going to divide by 2, and the 2's would cancel out. So here, the circumference of half the circle, of the semicircle, is going to be pi radius. Okay? And the radius is 5, because we already know it's 5. They tell us it's 5. So it'd be 5 pi. Yay, we already know the first part, 5 times 3.14. So that's the first part. We have to add that to find the perimeter. But then to find the perimeter of here, here, and here. Well, in here we have the top side, right? It's 4. So we have to add 4 because perimeter is also adding all the sides of the outside. Now this dashed line doesn't count and the radius doesn't count because that's just the radius. That's not part of the perimeter. The perimeter is the outside of the shape. And so 4. And so if this one measures 4, this one has to measure 4. It just makes sense, right? It's a rectangle. And then what does this measure? Well, this, I would say, measures the same as the diameter of the circle. And if the radius is 5, then the diameter has to be, yeah, that's right, 10. Good job. So 5 times 3.14 is going to be, well, we're going to have to multiply it right here. 20 and a 2 goes up. 12 and a 1 goes up. 16.20. Yep. So 16.2 plus 18, right, is going to be 34.2 meters. That's going to be my perimeter for the thing. Now in here they say it's about 33.7. Why did I have 0.5 more? Did I do this wrong? 5 times 4 is 20. A 0 and a 2 goes up. 1 times 5. Oh, it's because it's 1 times 5, not 2 times 5. Yeah, 1 times 5 is 2. It's 5 plus 2 is 7. 3 times 5 is 15. 15.7. Whoops. That's why you always need to check your work. 15.7. And 15.7 plus 18 will be 33.7 meters. And that would be the perimeter of the first figure. So please be careful with the math, right? I made a really dumb mistake here because instead of 5 times 1, I did 5 times 2. And then I added 2, which is not acceptable. And so that's why you need to check your answer. So perimeter is 33.7 meters. All right, so it turns out that the second example had to do with the first example, and so I'm gonna just move it a little bit because I was looking at some of the glare, so I'm trying to get rid of the glare, but I'm sorry, I don't know what to do with the glare. I need lights, but then if I turn them all off, obviously you can't see the board, you can't see the examples, but in the second part is area. So now we have to deal with area. So area of what? Of two things. We have area of, sorry, my cable got tangled here. There we go. The area of the semicircle, which is half the circle, and the area of the rectangle. So obviously for area of a circle, the formula is pi radius squared. Again, I told you at the beginning, you have to know your formulas. Area of a circle, pi radius squared. Area of a rectangle, base times height. We know that this base is 10. We know the height is 4. So the area right there is going to be 4 times 10. It's going to be 40. Down was pretty easy. Now this is the area of the whole circle. We need to divide it by 2 to be able to find the area of that. So it's going to be 25 times 3.14 divided by 2. So again, we have to multiply, and now I'm going to be way more careful than I was at first. 5 times 4 is going to be 20, and a 2 goes up. 1 times 5 is 5, plus 2 is 70, and 5 times 3 is 15. 0 is a placeholder. 2 times 4 is 8. 2 times 1 is 2. 2 times 3 is 6. We're going to add 0, 5, and a 1 goes up. Is going to be 8, 7. 78.5. Now we have to grab that 78.5 and divide it by 2. .5 divided by 2 into 2, it fits 3 times. Into 18, it fits 9 times. Whoops, I ran out of space right here. Into 5, it goes 1 time, but then again, it's going to be 39.25. It's going to be 39.25, and I'm going to check really quickly with the book. Oh, what do you know? I was right in that one. So then we have 40 plus 39.25. And that would be a grand total of 79.25 meters squared. Don't forget the units, please. But this is the end of example 2. And so we found the circumference of this shape and the area. So realize it's different formulas that we're looking for and that you have to memorize. And obviously always check your math. But the first thing to be able to even get to the point where you check your math is know your formulas. Area of a square, area of a rectangle. All right, so in example number 3, we have to find the area of this sector right here. Okay, the one I'm coloring in. Beautiful. I know how to color. I passed kindergarten. I did not get outside the lines. Yay. Do not color outside the lines. Look at that. Beautifully done. My kindergarten teacher would be proud. All right, so after we actually, to be able to find the area of the sector, we have to go back to the area of a circle. Area of a circle is pi radius squared. Okay, but that's for the whole circle. Are we looking for area of the circle? No, we're looking for the area of this. It's like if they ask you how much area of the pizza did you eat? Although I don't know who would ask you that, but maybe you don't know who's out there, wanting to share pizza with you, but also wanting you to do some math about it. And so what you need to understand here is that the whole circle is 360 degrees, but in here we only have 300 degrees, and the radius is 6. So they give us the information that we need to be able to do it. So the first thing that we're going to do is you have to find the area of, or know the area of the full circle, right? So we're going to do that. We're going to pretend that we're going to be finding it, all right? So we're going to do 36. Why 36? Because 6 squared is 36 times 3.14. But wait, we're not going to actually just find it right now. What we're also going to do is find the fraction of that we're looking for. Because if it was a pizza, it's obviously cut into parts. We need to know what fraction it is. Because this right here, the sector measures 60 degrees. Where did I get 60 degrees from? From 360. Because 360 minus 300 is 60. So because it's 60 degrees out of 360 degrees, that is the fraction of the sector or the area. That's a fraction of the area that we have to find. So the degrees cancel out, the zeros cancel out, is 6 over 36, which cancel out and becomes 1/6. So then we have to actually find 36, 3.14 over 1 times 1/6. But when you do that, these two cancel out, and so it's 6. This is why I didn't want to multiply right off the bat, because I knew this would simplify. And so then we just have to find 3.14 times 6. 6 times 4 is 24, and a 2 goes up. 1 times 6 is 6, plus 2 is 8. 6 times 3 is 18 centimeters squared. That is the area of the sector that you have to find, 18.84 centimeters squared. All right, for example number 4, what we're trying to do is find the arc. So the arc is actually the outside part of the sector, or the part of the circumference that has to do with it. So that's called the minor arc. And because, why is it minor? Because it's the smaller of two arcs. We have two arcs here. We have arc AC, and then we have arc ADC. Beautiful. All right, so we have two arcs, right? And the two arcs add up to give us the circumference, or the surrounding part of the circle. So they say that this one right here is 70 degrees, and the measurement of AOC is 70 degrees. So they're asking us, what is the measurement of the rest of the circle? That is pretty easy, because we know all circles measure 360 degrees. So we subtract 70 degrees, and then we're going to get 290 degrees, and that's it. That's literally it for example number 4. Okay, and then in example 5, they tell us there is a part of a circle that is drawn from 2, 0, 2, 0, 2, or from the 2 in the y-axis to the 2 in the x-axis. Seeing that the origin of the graph of the x and y coordinate plane is going to be the center of the circle, right? And then they tell us, what is the arc? What is the measurement of this part right here? Okay, so the arc is not the area, but the outside, the circumference of that little part that we drew. So the circumference, obviously you have to know circumference equals pi diameter, or diameter pi, or circumference also is 2 pi radius. Okay, so we're going to use the one with the radius because it makes more sense. But we also have to find the measurement of this angle. And lucky for us, it's going to be 90 degrees, because we know that in here, it's going to be 90 degrees. So that's going to be 90 degrees. Why is it important? Because we need to find out the fraction of the circumference that we're looking for. So the fraction of the circumference is going to be 90 degrees divided by 360 degrees, which is going to be 1/4. Because 9 over 36 is 1/4. right? Yay. So what we're going to do is we're going to use, let's use this one. Actually, I think that one's would be really easy. So the circumference would be 2 pi times 2. Why 2? Because that's a radius. The radius is 2 here, and the radius is 2 here. So 2 pi 2 times 1/4. Well, look at what's going to happen here, okay? That's one of the reasons I said, let's use this one. It's going to be really easy. 2 times 2 is 4, right? So it's going to be 4 pi, and then this 4 is going to be over here in the bottom, and so the circumference is going to be pi. Literally, this is pi, or if I approximate, is going to be about 3.14, and the units are units? Yeah, units, 3.14 units. And I'm done. That is the end of lesson 104, and yeah, that's it. So I will see you tomorrow for something I think it's surface area, which is something that I hope that you guys get. And again, tomorrow is really important that you guys know the formulas for area of things like triangles, rectangles, squares, and circles, okay? So yeah, that's it for today. I'll see you tomorrow.